Good morning. It's Mrs.Z. Today we have grade 6, mission 6, lesson 17. Lesson 17, two related quantities, part 2. And here is warm up. Yes. Okay, Lynn and Jada each walk at the state. Okay, let's start all over again. Sorry, guys. I need to move this. So Lynn and Jada each walk at the steady rate from school to the library. Lynn can walk 13 miles in 5 hours. Jada can walk 25 miles in 10 hours. They each leave school at 3 o'clock and walk 3 1/4 miles to the library. What time do they each arrive? Okay. In the text, there's little tiny space, like this much to do work. So we're gonna use our notebook, and then just put lesson 17. 17, oops, Z. 17 and warm up. Okay. Okay, so now let's think about what do we have. It says there are two girls, and then Lean. If I create a graph, one girl is called Lynn, and other is called Jada. Okay. Now they gave us information, so I'm going to use the table for Jada and table for Lynn. Okay, parallel down, right? So, okay. So now when we have two different data, the first we'll think about how we can label our tables. So 5 hours, that's Lynn, okay, and hours would be on the top hour, and then other side are miles. Okay, and the same thing for Jada, hours, and then miles. Now, 5 hours, Lynn can walk 13 miles. And then Jada can walk 25 miles for 10 hours. Okay, so when we know that, they says they each leave school at 3 o'clock and they walk 1/4 miles to the library. What time do they each arrive? So first, I would like to know how much is 1 hour, how many miles, or if I want to know 1 mile, how many minutes is or hours it is. So because we needed to know how many minutes, I like to know how many minutes it will take them to arrive to the library. So we'll go think about we need a 1 hour or unit rate. If I look and think logically, I could say that this is like dividing by 13. So to find 1 mile, how many hours, or or I could use how many miles is in an hour. So let's see, if I do this, 1 mile, how many hours? It would be divided by 13, correct? Divide by 13 or multiplying by 1/3. Okay, that's the same thing, multiply by 1/13. Okay, so that will be, give me, the value is 5/13 is that. Now if I look, so that's 1 mile is 5/13 of an hour. If I look here, hours and miles, there is already 10, so I can say that is, if I divide by 25 or multiply by 1/25, I will get now what is 1 mile for this, and 1 mile is 10/25. So if I know that 1 mile is 10/25 of an hour, then I can think of simplifying these fractions. So I can, or I can think that the three next value that I need to find, that means how many 3 1/4 of a mile they both walk. So how many of these they will walk. So this was original values, and then we found unit rate, which is this one. Okay, for 1 mile, there is 10/25 here. For 1 mile, there's 5/13 here of an hour. So the question is, how many is 3/14? In this case, I like to see 3/14 as same as just fourths. So if I have a fraction part, I like to have all the pieces there. So when I'm thinking that 3 wholes can make 12 fourths, and one more, then that will be a 13/4 that I will have. And the same thing on the other side, this would be 13/4. Okay, I can see this. This can help me with calculation, because now if I go and multiply 1 by 13/4, I will get 13/4. But then also I need to multiply other side, which will be my 5. So to find, sorry, this, okay, so it will be 1 times 13/4 is 13/4. So that I'm gonna repeat one more time this, and then also this will be 5/13 times 13/4. So going from 1 to this is multiplying by 13/4, and also from here to here it will be that. But I will calculate right here so it's easier for me. Okay, now when I look that, I can write a very simplified 13 and 13. Divide by 13, they both get 1. And then 5 times 1 is 5, and 1 times 4 is 4. So for that value, 3 whole miles and 1/4 of a mile, or 13/4, they walk, lean walk 5/4 of an hour. While if I look this, it's going to be 1 times 13 13/4 to get 13/4, correct? And then here needs to be as well 10/25 times 13/4. Okay, now I can simplify this way because 13 is a prime number, but I can do 10 and 4, so I'm going to divide by 2, and here will be 2 left, and then 5 would be left here. So now all I needed to is think this is 13/4, and then here I will have 5 times 13. So 5 times 3 is 15. 5, remember 1. 5 times 10 is 50, plus 10 is 65. And what they are is 25 times 2 is 50. Okay, that's one way of looking into this. So right now I have, I'm gonna make it smaller. Okay, so right now I know that 13/4 of a mile, 13/4 mile is same as 65/50. When you look this, you can now change this value into the time because it has to be in hours. So 5/4, it means really 1 hour. 5/4 has 4/4, which is 1 hour, and it will be 1/4 extra. So 1 and 1/4 of an hour will make this 3 holes and 1/4 walk. If I look Jada is, so now I have 50, I need a 60 there. So I needed to think about how I can simplify that to fit 60 minutes increment. So if I divide, I can show you here, like, so let's see if I have a 65/50s. So I'm going to divide by 5 both first. Okay, so I'm going to get 5. It's so if I do this, you can say 65 divide by 5. So 1 times 5 is 5, make this, and then it's 13. 5 times 13 is 65. So you will have here 13s. 13 tenths. So now if I multiply by 6, then it will give me exactly how many minutes is that. 3 times 6 is 18, 78, 60s. So now I change this expression into this, and it means the same, because right now I can see that 60 minutes is hour. So I have in 78, I have 60 minutes. So I have an hour, and there is 18 more minutes left. So 1 hour and 18 minutes. 1 hour and 18 minutes is how much Jada took. So I can say this 1 hour and 1 hour and 18 minutes. Took her to walk 3 whole miles and 1/4 of a mile. While if I look this one also 1/4 of an hour, I know it has to be 15 minutes. I can prove it by 1 hour and 1/4 times, if I multiply what I multiply by and I get 60, it's 15. So when I multiply that, I got 1 hour and I got 15 60ths, which is 15 out of 60 minutes. So here, this is 15 minutes. So 1 and 1/4 is same as 1 hour and 15 minutes. 1 hour, 15 minutes. So one girl walked 1 hour and 15 minutes that distance, and then one girl walked 18 minutes, same distance. So now they say this. I can do that in our notebook because the answer says, what time do they each arrive? Okay, so now if I take my data, what I calculated that. Here is Jada, and then here is Lane. So now we know that both start at 3 o'clock. Sorry, I need to make this. They both start at 3 o'clock, and so then Lynn walk 1 hour and 15 minutes. So plus that. So that would be, she will be there at 4 o'clock and 15 minutes. And then Jada did 1 hour and 18 minutes. So she's going to be there at 4 hours, 4 and 18. So what time did they each arrive? Lynn arrived, 2 hours, sorry. Arrived at 4:15 p.m., for example, and then Jada arrived at 4:18. So Jada came 3 minutes after Lynn. All right, very hard warm-up. Don't you agree with that? It's just a lot. Okay, guys, let me just clean this a little bit. So that's, and then this one is also arrived. Okay. Next activity is, it says, I just want to show you how much we did work on this one, just to warm up. What's this whole thing? Warm up. And then plus additionally that. Next, Diego. Right. It says make nice and visible. Right. Okay, this will be it. Right. Now there are 3 names: Diego, Elena, and Andre. Participate in a walkathon to raise money for cancer research. They each walk at a constant rate, means the same constantly. They didn't change faster or slower. They just had the same pace. But their rates were different. So depend how big step is, each of them have more or less steps along, but these steps were consistent or under constant rate, if you think that. Now, complete the table complete the table to show how far each participant walked during the walkathon. I don't know what that means, walkathon. Sorry, guys. Okay, complete the table. So I always, you look the labels first. Time in hours. So this is just 1 hour, and how much Diego, how many miles he walked, and how many Elena miles walked, and how many Andre miles. So here's the time in hours. So this is unit rate. So we need to find each the value, how much is 1 hour for each of the student. That's the goal. Okay, so I can't do much here, but I can see that, for example, they say, like, if this is 2 and this is 6, so 2 times 3 is 6. So this would be, if this is Diego's pattern, it goes by multiplying 2 times 3. So right here, I can see that Diego's pattern, then miles is, or distance, we can distance for Diego, distance is 2 times 3 equals 6 for this one. And then if I go up, distance for 1 mile will be 1 times 3 equals 3. So now I know that here has to be 3 miles, because if he walked 2 hours, 6 miles, he worked 1 mile, 3 hours. So we kind of have now we could have his distance as the formula. So any distance that Diego made, it will be d equals 3 times 3 times t. So time, 3t. So distance 3 times. So now if I look how he has already 12 here, so how many days that would be? So I can plug my information. This is already, I know that is 12. So distance is 12. They gave us information. But if I use my formula for Diego, I can supplement the values. So now I know the distance is 12, and I know that the relationship is a constant times 3 times 3. So times 3t. So now 3 t's is 12. How much is 1 t? So if I divide both sides by 3, like we learned, then I will isolate t, and t for Diego would be, for this 12 miles, he will walk 4 hours. So here needs to be 4, because 4 times 3 is 12. And we found the formula or for the Diego. So now if they give us for Diego here 5, so 5 times 3 will give us what? It will give us 15 hours, 15 miles, sorry. So when we plug in this 5 hours, we'll know then the distance equals 3 times 5, which is 15. Okay, we finished Diego. Now we're going to go to Elena. And now we're thinking, what do they give us for Elena? They give us only this. And then, of course, we know that that has to do something with the hours, because they say for 4 hours, Elena walked 11 miles. So when we do that, we can formulate her her equation. So if this is Elena, so her distance is equals 4 is 4 times 4 times t, 4 hours times t. So if we already know that d is 11, we should substitute that. So we're going to say 11 is same as 4 t's. Okay, so because now if I divide by 4 both sides, I will get that Elena's time for Elena's unit per hour would be 11 fourths. Okay, 11 fourths. So right here for the one value, I can say that Elena is 11 fourths. Now, if we think what is 11 fourths, then we have to divide 11 into 4 pieces. So if I go and use my margin, so this will be 11 divided by 4. So how many fourths are in 11? There are 2. 2 times 4 is 8. When I subtract, I will get 3 left. Okay, group. And then I know now I have to put the decimal, bring down the 0. So again, I have 30. 4 times 7 is for 28. When I subtract, I got 2 left. I'm going to get again 0. And then now I have 20. How many fourths are in 20? There are 5. So 5 times 4 is 20. And then I don't have leftovers. So I know this is equals to 2 miles and 2.75 miles. So right now from this value from here, I knew what this then the time for 1 t is 2.75 miles. Okay, or 11 fourths. 11 fourths. That's another fraction. So now when I know how much is 1 hour per mile, I can do the rest here. So right now, 2 times this would be value here. 5 times this will value here. So 2 times 75 is 275 plus 275. So if you do multiplication or you do addition is the same. So 5 miles, 5 and 50 hundredths of a mile is for 2 hours. Okay, next would be 5 times this. So let's now use multiplication. 275 times 5. 5 times 5 is 25. 5, I remember 2. 5 times 7 is 35. And 2 is 37. 7, I remember 3. 2 times 5 is 3. 10 plus 3 is 13. Okay, so it should be here 13 miles, 0.75. Okay, so now we're done with Elena. We move to Andre. Okay, so I will use that only information for Andre, we have this one. That's how many miles he walked in 5 hours. So if I find the formula that goes for this, it would be the distance for Andre would be 5 times t. So distance would be, oh, I'm sorry, you need to substitute this. I can also say 5t's like this without multiplication. D equals 5t's. I already know the distance, so I can put 17 5/10 must be 5t. So I want to know how much is 1t, like I did here. I wonder how much is the 1 hour or the 1t. So I'm going to divide by 5 both sides. And then I will have what Andre's 1 hour, how many, 1 hour, how many miles did he walk? Okay, let's now divide. So if I have 17 and 5/10, need to divide into 5. I can, so 5 cannot go in 1. If I have 10, I cannot share equally. But if I have 17, I can have 3. 3 times 5 is 15. So when I subtract, I have 2 left. I'll bring down the 5. So how many 5s are in 25? There are 5. And the decimal is in the same line above. So 5 times 5 is 25. And I have no remainder. So my answer is that for 1 hour, he walks 3.5 miles. So finally, we got that to find unit rate for our miles per hour. 3.5 miles for 1 hour. That's Andre. Or we can also see as this, if I want a fractional parts like this. All right, so now when I know that 1 is 2, 2 times 3.5 is 7. 3.5 plus 3.5 is 7. Now 4 times 3.5 would be already, you already have this 3.5, and if you add 7, that would be 10.5, and then if you add 3.5, that is going to be exactly 14. If you don't believe me, you can add, or you can say 4 times 3.5. So let's see, 3.5 times 4. 4 times 5 is 20. Remember 2. 3 times 4 is 12, plus 2 is 14. I have 1 decimal. I have tenths. I need to say the tenths. So that's what it's all about. So 14. And now I have all the values. For the comparison relationship between Miles, Elena, and Andre, and we found a unit rate for both. What that means, this is how fast was each participant walking in miles per hour. So miles per hour. Okay, so how we know how we're going to set that is if I say that Diego, he walks how many miles per hour? He walks 3 miles per hour, per 1 hour. Or we can see 3 miles per hour, like this, 3 miles per hour. That can be. Sometimes you will see the same like this, 3 and then miles slash hour. That's also the same as. Now, Elena did 2.75 miles per hour. Miles per, I'm going to put per here, per hour. Okay, so it is 2.75 miles per hour. And then Andre did 3.5 miles per hour. Okay. Now, next is going to be, I think we needed to do graph. So we have the data here, but now we have to plug all the data in here to graph these each of these people. So I like if I can rewrite, to be clear, rewrite each of these into on the side so we can see. Right, okay, so we can see how we're going to, and which color we're going to use to find the data for each. How long, it says, how long did it take each participant to walk 1 mile? Okay, we didn't answer that one yet, so we will see how that goes. All right. So if I look, I forgot to answer number 3. So let's go back to that one. So now they want to ask opposite. Look, we did 3 miles for an hour. So 2.75 for an hour, 3.5 for an hour. Now they want to opposite. They want to see how much is 1 hour. It's 1 for 1 hour. So he did 1/3 of an hour. So Diego walk 1 mile, 1 mile for 1/3 of an hour. Okay, and then Elena did 1 mile. Okay, Elena did 1 mile for 4/11 of an hour. Because we flipped this, look, reciprocal. So 11/4 was, and now it's 4/11, and it was 3. But when we think about terms of hour, there is 1/3 of an hour. So that means, and then also put mile, and Andre did. He walked 1 mile for 2/7 of an hour. 2/7 of an hour. Okay, so that's it. Now we're gonna graph. I'm going to use this to make little tables. So if I do the times is x, and then miles is y. So miles is y. It's important to label correctly. This is y-axis, and then this is x-axis. And if this is data for Diego, then it will be 1x 3 y. Okay, and then it will be 2 and 6 and 4 and 12 and 5 and 15. Okay, those are the values that I took from the outer table. And then if I look now, others, so that could be Elena. So Elena did T for it. It's going to be X. Miles going to be Y. And then we look now. So time, you look always label time is X. So then means Elena will be 1 hour is 275. 2 hours 515. 550. Number 4 is 11, and number 5 is 13 and 75. We can always have more points if we need. And then I will do Diego on this side. Oh no, the Andre on this side. So it will be Andre time x miles y. And 1 hour for 3.5 miles, 2 hours 7 miles, 4 hours 14 miles, and 5 hours 1375. Now when I have all these, I can now choose to, let's see if Diego is blue, or let's see Diego purple. Okay, I can do Diego purple. So 1, 3. So X is 1. Okay, I need to see. X is 1, and make it a little bit bigger so you can see all of it. Okay. All right. So I'm plugging in these 2 coordinate points, X and Y. For X is 1, I need to go up to 3, and this is it. They keep counting by 2, so you need to figure out 3 is right here. So 1 and 3, Diego, that's going to be right here. Okay, then I have 2 and 6. 2 and 6, that would be right here. Okay, then 4 and 12. 4 and 12 is right here. Check double, yes. So that's the his third point. And 5 15s, 5x 15 is right in between 14 and 16. So the point is right here. So now all this represent Diego. Okay, now I did plug in all the points. Now I'm going to do Elena. Elena can be pink. So 1 is 275. 275, I can see it as like 2 3/4. Okay, that's 75 is 3/4 as a fraction. So if Elena is 1, she is 2 3/4 of, so here's the 2. Okay, now I need to make it bigger. Okay, make it a little bit bigger, right? So I'm plugging in this her points. So I know that she is x is 1, y is 2 75, which is 2 3/4. So here's the 2, but I now can cut these into 4 pieces, and then the 3/4 is about right 1, 2, 3. So it's right here. So I can do the dashes if I wanna. So her point is right here next to the vehicle. Next is 550. If I look 550, that's about 5.5 as a fraction. So if I go 2, I need to find 5, and 5 is right here, but it's 550, so it's in between the 5 and 6, so it's going to be right here. So when I look that, point is going to be right here next to it. So now for 11, 4, and then I go all the way to 11, 11, 10, 11. So here's, if I need a help, I can use my ruler. That's 11, and then this is 4. So this is where her point is. And then 5 is 1375. 1375 is same as 13 3/4. So 5 is all up to 13. Here's the 13. But also 3/4. If I cut in a half, and again half and a half, the 3/4 would be closer to 14. So it's about right here. So 5 and will be right here. Okay, so I plug in 1 and 3/4, 2/4, 1 and 2/3/4, 2 and 5.5, 4, 11, and 5 and 1375, which is 13 3/4. Okay, Elena, done. Let's see if I take red to be Andre. So now first is 1, 3.5. So x is 1, and then y is 3.5. So here's 3, and in between 3 and 4 is a half. 3.5 is right there, and then 1 would be right here. So like this, if you look at. Okay, so Andre is here. And next, his point is 2, 7. Okay, so 2 is right here, and 7 is right there in between 8 and 6. 7, 2, 7, and 4, 14. 4, 14. Here's 4 all the way to 14. 4 all the way to 14. It's right here. Okay, and then the last one, 5, 1375. 5, 1375, same like 1375 is 3, 13, 13 and 3/4 of the next number. That's easier to figure it out. If I look 13 here, and then 3/4, that means 1, 2, 3/4. So it would be right here on the same spot. 7. Oh, I messed up, guys. That was not. They cannot be on the same point right now because I miscalculated. I wrote 1375, but I needed to 17.5 to do. So here is the 17.5. So that's good. I catch my mistake. When you're doing work and you show your work, you can easily spot your mistake. So then you can fix that mistake. So then this means 17, 570, 17 and a half. So it's 17 and 1/2. 17 and 1/2. Right. So 5 is right there. So we'll go all the way to 5. Oh, here's the 16. And here's 17. But we need a half more. So it's in between 17 and 18. I can use my ruler. I know the 5 is in this. So the point is going to be right here in between. And that is actually what? Red. Sorry. That should be red color. Red. I can see then these are all linear. And I can even do this. So I can draw a line for my Elena. That's her equation. And then I can draw pink for Diego. This was Diego. And then I can use red for Andre. I can also show you. So that's time. Let me see. This is Elena. This is Diego, and this is Andre. And if you look, they all start with the 0 because every all the lines would be end up with the 0 where they starting point. If I look, you can see then they all start with 0, and then where they start walking, correct? So here they accordingly do it 0, 0, and then they move in their constant rate so that the graphs are a little bit different because they don't have the same pace. Okay, so if I want to do, I can write these equations that I find, and that is like this would be, I want a precision, so y, this would be y equals, this is Elena. Elena is y equals, the distance is 2.75 t. Okay, so 2 3/4, and then t is y. X, sorry, x. X isn't, so this is independent, and this is dependent variable. Now, if I want to write that the blue and the purple is Diego, his is y equals 3, 3x. Okay, right, 3x. And then Andre is y equals 3.5 x. Guys, this is really probably a lot, but these formulas are very important. It tells us dependent variable is y, and how we can find any points on the number line or any points on these. In even further, we can use the same formulas that we just did. Find out. Right, okay. Right, let's see if I can that a little bit. Right, so it's now how it looks like. Okay, next, Diego said that d equals 3t represents his walk, where d is the distant walk in the miles and t is the distance in the hours. Explain why d equals 3t relates to distance Diego walking to the time it took. So it is just what I just explained. Diego's is purple, so y equals 3x. So for any point. So they have the distance Diego makes. The distance is same as 3 times the time, or y is equals 3 times x. 3 times x, right? So Diego walked 3 miles in 1 hour. So that's what we can explain. Diego walked 3 miles in 1 hour. Okay, so you can multiply number of hours by 3 to find the distance. So I can find room to write it down. Okay, how about if I say that we could put any points. Let's see if I want to find what is we have here 5, correct? It's 15. So what if I say x is 6? What would be the point? So we can figure it out, because what distance formula is 3 times t. If we say t is 6, what would be the distance? 3 times 6, distance would be 18. So the points for this would be the 618. So it would be 618. This is x and this is y, or this is the distance and this is the time. Okay, let's talk about write 2 equations that relates distance and time for Elena and Andre. So this was Diego, and this was his equations, and then or with when we substitute distance to be y and x to be t. If we do Elena was that distance is equals 2.75 t, Okay, Elena. And then I can see that also as D equals 2 3/4 T. Okay, I can also substitute that to be, if the distance is what we are looking for, that's our y. And then 2 3/4 of x will give us y. And that is Elena. If we say for Andre is distance is equals 3.5 times t. Okay, so then the distance for Andre also could be seen as 3 1/2 t. And then if I needed to do that in terms of graphing, so I can say, oh, distance is dependent variable, that's y, and 3 1/2 t is independent variable x. So that is so t is time, that's what it is, x. And then the value for the miles or distance is a d, so the y is d. I hope that helps. All right, so that was, then we need one more on the back. Okay, number 6. Okay, it says use equation you wrote to predict how far each participant would walk at their same rate in 8 hours. So 8 hours. So now our formulas, that's what we can use to, what if they give us now t is 8, so we can plug that information and get our values for how long they will walk in 8 hours. So for Diego, formula was y equals 3x or d equals 3 times t. So the distance is 3 times t. So t equals, this is t equals 8 hours. That's what they say. They always give us 1 point. Okay, so now that would be d is 3 times 8, and then d is 24. So Diego will walk 24 miles for 8 hours. The points, if I want to graph it, the points would be x and y, remember? So remember that x was the time. So time is 8, and now we know this was unknown of point, but we know now that is 24. Okay, and then I can label this as well, T and D. Now this is Elena. Elena formula was this, D equals 2.75 times T, or 3/4. So it's up to you what is easier for you, to do the fractions or to do the decimals. So D equals 2.75 times 8, or so if I multiply 275 times 8, again 5 times 8 is 40. Remember 4, 7 times 8, 56. 5 plus 4 is 60. 2 times 8 is 16, plus 6 is 16 plus 6 is 22. And then I have hundreds, so that distance will be 22. 22. Okay. Go cookie. All right. That's so the point would be 8, and her point will be 22x. We can check what if I do the other way, 2 3/4 times 8. Okay, so 2 times 8 is 16, and this is partial product, and 3/4 of 8, 3 times 8 is 24 fourths. So 24 divided by 4 is 6. So you got 16 plus 6, and that is equal to 22. So that's another way to see Elena's calculation. Now, Andre's formula was B equals 3.5 times T. Now we know T is 8, so D equals 3.5 times 8. I can also see this as 3. D equals 3.5 times 8. Okay, so if I do that, I can say 3.5 times 8. 5 times 8 is 40. Remember 4. 3 times 8 is 24. Plus 4 is 28. Only tenths. So D equals 28. Okay, now if I do the fraction ways, I can say 3 times 8, 3 wholes times 8 is 24 wholes. And then I also can think 8 times half is what is 1/2 of 8, and that is 4. So that D equals 28. So, Andre can walk 28 miles for 8 hours, Elena 22, and then Diego 24. So if I want points for Andre, 8 will be X, 28 would be Y. For Diego equation and equations you wrote, which is dependent variable and which is independent variable. So now they say here which is for Diego's equation, or for any, we can see which one are independent, which are dependent. So let's see, Diego's was D equals 3t, or y equals 3x, right? So the t is given or chosen. So I can choose t to be 8, I can choose to be 10, 20, 50, it doesn't matter. But depend what I choose, I will get d or distance or y, the value. So this is dependent on these values. So this is independent variable. Also this. And then these, this and this are dependent variables. Okay, so I hope that helps. And that was ZEARN lesson 17, grade 6, mission 6, lesson 17. Guys, lots of work we did. I hope that you understand it. It's not easy, but if you try, you can make it work. Was also very hard to do, but I'm hoping that you can see the product of our work. All right. Okay. See you next time, guys. Thank you for listening. It was Mrs. Z. Goodbye.